Welcome back. So, today we're going to walk through a series of papers that propose something truly radical. We're talking about a whole new foundation for physics. The claim that cosmology's biggest puzzles, all of them, can be solved not with new particles, not with extra dimensions, but with a kind of geometric code that's been hiding in plain sight, right in the vacuum of space itself. You know, we usually treat these big problems as separate mysteries, right? Dark energy is one thing, the Hubble tension is another, the structure of the CMB is yet another. But these papers ask a really powerful question. What if we've been looking at this all wrong? What if they aren't separate problems at all, but just different symptoms of one single underlying physical principle? So what is this master key? Well, it's not some exotic particle from a super collider. It's three constants you learn about in first-year physics. We're talking about the vacuum permittivity, epsilon naught, which is basically the vacuum's capacity to handle electric fields. Then you've got the permeability, mu naught, which does the same for magnetic fields. And finally, the impedance, z naught, which defines the ratio between the two. The argument here is that these aren't just passive background numbers. They are the active fundamental properties that define space itself. Now, here is the absolute core of the idea. Imagine these three properties, capacitive, inductive, and resistive, as being orthogonal, like x, y, and z axes in a hidden dimension. The theory argues that what we actually see, what we experience as our universe, is a 2D projection of that deeper reality. Think of it like a 3D crystal casting an intricate, repeating 2D shadow. And that shadow, that projection, isn't random. It naturally snaps into a perfect three-phase geometry. This geometry becomes the literal blueprint for, well, for everything. Okay, so let's put this blueprint to the test. First up, dark energy, the whole mystery surrounding the accelerating expansion of the cosmos. And the key parameter we're looking at here is its equation of state, which we just called W. Now, as you know, the standard model of cosmology, lambda CDM, is incredibly rigid about this. For dark energy to be a cosmological constant, W has to be exactly -1, period. But our best recent data from DESI is telling us something else. It's giving us a value that's off by about 3 sigma. That's a big deal. The theory and the observation just don't line up. Okay, so how does this new theory handle it? Well, this is where it gets really powerful. It doesn't just pull a number out of a hat. It derives the observed value from that geometric blueprint. Let's just walk through it. The geometry dictates 6 fundamental modes of oscillation for the vacuum. These split into a 5/6 chunk that creates background pressure and a 1/6 chunk that's the kinetic part. That's us, that's matter. Now we apply a tiny but crucial correction based on a fundamental rule. A wave can't interact with itself. This adjusts the math by a factor of 35/36. You follow that chain of logic, and it spits out a very specific number, a frequency scaling exponent n, which equals exactly 35 divided by 72. That's the key. So you take that exponent, 35/72, and you plug it into a completely standard cosmological identity that relates it to dark energy. W equals n/3 minus 1. You just do the arithmetic step by step with no free parameters, and you arrive at this exact, irreducible fraction. And just look at that. That is the punchline. The prediction, derived purely from first principles of the vacuum's geometry, lands dead center on the value measured by DESI. There's no tension here. While the standard model is struggling, this prediction is a perfect match. That's a remarkable result. So, let's see if this principle can work its magic on the next big crisis, the Hubble tension. You know, that decade-long war over the true expansion rate of the universe? The problem, as we all know, is painfully simple. Measurements of the local universe give us a value around 73. Measurements of the early universe give us a value around 67. The error bars don't even touch. It's a fundamental contradiction that has a lot of very smart people scratching their heads. So what's the solution here? Again, it comes from the vacuum's inherent properties. The theory argues that the vacuum isn't just empty space. Its three-phase structure makes it a natural waveguide. This means that over billions of light years, the group velocity of light, the speed of the energy packet, is actually just a tiny bit slower than c. The individual photon phases still zip along at c, but the overall wave packet experiences a cumulative drag. Now, that physical effect has an immediate mathematical consequence. It means Hubble's law, the simple linear relationship we've used for a century, is actually just an approximation. When you account for this drag effect, the real relationship between distance and redshift turns out to be logarithmic. And that, of course, changes everything about how we calculate cosmological distances. So, what's the real value for the Hubble constant according to this theory? Well, from those same vacuum constants, it derives a true underlying value of about 71.5. And you'll notice that's sitting right there in the no man's land between the two warring measurements. So how do we connect this true value to what's being measured? Simple. You calculate the bias. If astronomers are using the wrong formula, the linear one instead of the logarithmic one, they are systematically overestimating the expansion rate. And this bias is perfectly predictable. At the average redshift for the local SHOES measurements, the bias factor is about 1.02. So you take the theory's true value, 71.48, you multiply by the calculated bias, and you get 73.04, a perfect match for the local measurement. The Hubble tension, it seems, might not be a tension at all. It might just be a century-old math error. All right, let's move on to the holy grail of cosmology, the cosmic microwave background, that baby picture of the universe, with its power spectrum of peaks and valleys that tells us so much. Now, Lambda CDM does a beautiful job fitting the CMB data. We all know that, but it's a fit. It relies on 6 free parameters that are adjusted to match the observations. This new theory makes a much, much bolder claim that it can predict the locations of those acoustic peaks from first principles, using only those 3 measured vacuum constants. No fitting, no tweaking, just pure prediction. And, well, the results speak for themselves. The predictions for the first 3 major peaks are astonishingly accurate, well within observational error. But here's the real kicker. The theory predicts the ratio of the 3rd peak to the 2nd peak must be exactly 3/2. Why? Because it's a direct consequence of the ratio of phases to quadratures in the vacuum geometry. And the measured value? It's 1.497. It's spot on. Okay, at this point, I know what you're probably thinking. Is this just some incredibly clever numerology? Is someone just finding ways to make numbers fit cosmological data? The papers anticipate that exact skepticism, and their answer takes us from the scale of the cosmos right down to a laboratory bench. The proof they offer comes from these incredible experiments at MIT with tiny oil droplets bouncing on a vibrating fluid. Now, these are totally classical macroscopic systems, but they show bizarre quantum-like behaviors. Their orbits aren't continuous, they're quantized. And the reason, this theory claims, is that they are being driven by the exact same universal wave mechanics that structure the vacuum itself. And this, right here, is the final mind-bending piece of the puzzle. The math that describes the quantized orbits of these droplets involves something called Bessel functions. And when you look at the ratios of the zeros of these functions, the numbers that define the allowed orbits, you find the exact same integer ratios that were derived from the vacuum geometry to predict the CMB peaks. Look at the numbers. This isn't an analogy. It is the same mathematical blueprint showing up across 26 orders of magnitude, from a millimeter droplet to the entire visible universe. So let's just step back and absorb what this implies. We started with 3 basic lab constants. From them, a geometric blueprint emerged that, with 0 free parameters, predicted the equation of state of dark energy, solved the Hubble tension by correcting a century-old formula, and laid out the structure of the cosmic microwave background. Then, we found that same blueprint operating in a classical lab experiment. The final implication is absolutely staggering. If cosmological redshift is caused by light dragging, not by the expansion of space, then the Big Bang may have never happened. What if the universe isn't expanding at all? What if it's an infinite system steadily accumulating matter that crystallizes out of the endless, geometrically governed fluctuations of the vacuum itself? That is the provocative thought this theory leaves us with.